You did the work on Malgrange Weierstrass preparation theorems.
Yeah, there was a famous old theorem in complex analysis called the Weierstrass preparation theorem, which is for complex analytic functions. It's a way of factorizing them.
Right.
And Malgrange gave a real version of it, assuming just smooth, everything smooth function. And his proof is very algebraic, and he does a lot of other algebraic things in the paper.
Right.
And I found an analytic proof which mimicked the original Weierstrass proof. Weierstrass proof is in complex plane, and he uses the Cauchy integral theorem. So what I did was to extend the function, which is not analytic, into the complex plane, where it satisfies the Cauchy-Riemann equations to infinite order on the real line.
Right.
And then I also use an analog of the Cauchy integral formula for solving the inhomogeneous Cauchy-Riemann equations, and managed to push a proof through like that. And the simplest case, I'd like to mention the simplest case. It's you have a complex function of n plus 1 variables, real variables. So there are n x's and 1 t. And the function vanishes at the origin, and its t derivative doesn't. Then, in this case, the theorem takes the form, you can write it as a product of a function which doesn't vanish at the origin times t plus a function of x, as in the form of the Weierstrass preparation theorem, except you don't have analyticity.
Right.
And such a simple thing. If you're working with real functions, it follows from the implicit function theorem. I don't know a simple proof for complex functions. My proof is not so simple. It's such a simple question, I don't know a simple proof. In fact, some years ago, for a semester, I ran a seminar called Group Therapy for Analysts. The idea of the seminar was people will come with problems, questions, saying, look, I seem to need a lemma that looks something like this. I don't know how to prove it. Maybe somebody in the audience can prove it. Or there's this known theorem in the literature. I don't like the proof.
Yes.
Maybe somebody can find a better proof. And a number of problems were solved that semester by people in the audience.
So people participated in the discussion instead of the...
So I came with a bunch of prepared questions, and other people formulated questions, and a number were solved.
Oh, that's a wonderful idea.
Yeah, I only did it once, but I regret that I didn't repeat it. But you have to have a list of problems to get it started.
Yes, an idea of proofs you want to simplify or whatever.
Or things you want that you think are true and don't see how to prove. Yeah.
Right.
So this is one such problem. There is a proof, my proof of this question, and can somebody find an elementary proof?
But this proof also has been standing as the only proof for a very long time.
Oh yeah, it's the only proof, yeah.